Hello everyone, in this episode I will add two different things inside my TNP common utility classes. The very first one is a structure that lets me have a unique ID. So unique ID, and this guy is of course serializable inside system. We will have public static read-only unique ID empty equals to new unique ID, and here we send in a GUID dot empty. So we will have a constructor for that later. Then we have a private GUID, and we call it underline GUID, a private string, and it called value. Then we say a constructor that accepts a string as value. Come on, I missed that. The string value, and we don't need this here. Okay, and here we say GUID equals to decode, that's a method that we will add later, of the value. Then we will have another constructor that accepts a GUID, and here we say value equals to encode, and that's again another method we will add of the GUID. Okay, after that we will have a property public GUID, we call it GUID. Here we say get, that returns simply the GUID we have. Set, however, checks if the value we are sending in does not equals to the GUID first. If that's the case, then we want to say GUID equals to the value, and the string, the value, sorry, equals to encode the value we sent in. Then we will have another constructor for the value itself. So we say public string value. The get is simple. It returns the value. The set is somewhat similar to our GUID. So we check if the value we sent in does not equals to the value we have. Then we set the value equals to value. Then the GUID equals to decode the value we sent in. Okay. After that, we want public override to a string. Here we return the value. Okay. After this, we want a public override equals that accepts object. We say if object is unique ID, then we return GUID dot equals to, we typecast to unique ID the object, and another pair of parentheses dot GUID. Okay, or we can use underline here. Then we say if object is GUID, then we return the GUID equals to, we cast the object to the GUID, and we don't need this part. Then we check if the object is, not us, is string. Then we check the value, or the GUID equals to UniqueID object dot GUID. Okay, and you may say this won't work. We are typecasting a string to a class, but later on we will add some implicit classes, not classes, implicit methods that would convert our string to our class implicitly. So we return false at the end, because if we hit here, we didn't send in a unique ID or a GUID or a string. So we can't cast equality on that. Then the last override, public override, get hash code, and here we return the GUID dot get hash code. Now we add some methods, public static, that returns a unique ID, and we call it new GUID, or I can say create here. It's a better name. Then we return a new unique ID. We sent in the GUID dot new GUID. Okay. After that, we want public static string, and that is our encode method, the very first overload of it. It accepts a string as value, and we say GUID new system.GUID, we call it GUID equals to new GUID with the value we sent in, and finally we return, we call the next overload encode of the GUID. Okay, now the next overload, public static, not string, public static, it returns a string encode. Here it accepts a GUID, and we call it GUID. And this system is redundant. Why are you added that? Okay, so this is the bulk of our encoding. We say string encoded equals to convert dot to base 64 string the GUID dot to a string, no, to byte array, sorry. So after that we say encoded equals to encoded, not that, encoded dot replace, so we replace the forward slash in that to underline, and then we replace the plus in that to dash. Okay, because plus and forward slash are things that we may get inside the encoding of converting the GUID to a string, basically. Then we return the encoded dot substring of 0,22. Okay, so this will encode something like B17.5 C14 D296 4B0F A09A 03017 F4461F. That's a hash code for that's a GUID for you. It will convert it to something that like this: capital F, capital E, S1 S, X1S, capital Z, B, capital S, D, 0, U, G, M, G, capital M, A, F, underline, capital R, G, H, W. So this is the GUID. This is the string we converted to, okay? Now, when we encrypt something like this, we want to decrypt it back if we want to. So public static, and it returns a GUID. We call it decode. We send in a string as value. Here we say value equals to value dot replace. So we are moving backwards. So we want to replace underline with the forward slash. Then dot replace, we replace the dash with the plus, so we replace them back. After that, we get a byte array, and we call it buffer equals to convert dot from base 64 string the value, and the thing that we removed with that substring was 2 equals at the end. Okay, so we add it there. After that, we want to create a GUID from this byte array. It's really easy, so return new GUID, and you see that it accepts a byte array, and we have the buffer. Okay, now the next thing we want is some operators. Operators are those equal sign, not equal signs inside if conditions. So we say public static bool. Here is an operator. The operator we want is equal. It accepts a unique ID we call X, comma, a unique ID we call it Y. So it's comparing X to Y. We return the X dot GUID dot underline GUID actually, and compare it to Y dot underline GUID. So we can completely operate equal on GUIDs. We are using that. It is saying that when you have equal, you need not equal, so we generate that, and it's really simple. It just calls the not equal on the X equals to Y. Then we want those implicit conversions. So public static, and it's implicit operator, and it implicitly converts the string. So we send in a unique ID, and we call it ID. Then we say return ID dot underline value. So we implicitly convert a unique ID to a string. Okay. Then we want other implicits, and let me take a look at my notes. Actually, three more. So the first one is implicitly returning a GUID from a unique ID, and here we want the GUID, for example. Simple. The next one is implicitly converting a string to a unique ID. So unique ID is the return type, and here is the string, and we call it value. So we want to return a unique ID, and by constructor we can send in a string, so we send the value in. The last one, we want to convert any GUID to a unique ID. So again, unique ID. Here we accept a GUID and we call it GUID. So we return a new unique ID and we send in the GUID. And that's it. We now have one error here. Return GUID, and I forgot a semicolon. Okay, so if you recall, somewhere around here we had a string and we were implicitly converting it, and we had an error. If I find here, okay, so now the only error I'm getting is that inspect possible invalid cast exception. I will disable it once in file with comments. Okay, it will add something like this on the top: resharper, disable, blah. Okay, what it was saying that, hey, object may not be a valid unique ID. Well, we know that object is a string, but we are implicitly converting this string to unique ID. Okay, so we have our unique ID. Let's add a class called test. Now inside test, I can have something like this: string, and it should be constant. It should be static string, and we call it t equals to something like my name, alireza, and then we say unique ID ID1 equals to t. We implicitly converted the text to a string, or we say GUID in system dot new GUID, okay, dot whatever. So we are implicitly converting a GUID to an ID, or vice versa. We can say after that we can and make it static, so I can use it. We can say that, for example, private string f equals to our ID1, and we are implicitly converting a unique ID to a string, or we can say private GUID g equals to ID1. So we are implicitly converting back the unique ID to a GUID. Okay? There we go, our test. Now, the next thing I want is an interface. Actually, it's very simple. iCopy. The iCopy interface puts out a generic type, and it returns a generic type with the method called copy. Let's try its using. So I will implement iCopy with the type of test. And now we can implement missing members. All it's doing, as you can see, it returns a copy of the test class, and we return null for that, so that we don't have any errors. So it's just an interface that I use inside classes that needs to return a copy of the same class. Last one. You may not know it, but actually, dictionaries are not serializables inside, and I like to be organized. Dictionaries are not serializable inside Unity. So dot interface, and let's make it not plural. Okay. Dictionaries are not serializables inside Unity, so we want to have a serializable dictionary. Fortunately, I think from Unity 4.x, we have two calls that we can use. So let's add a class. I call it Serializable Dictionary. And of course, it's serializable. And I set it so that I can have the serializable in front of the name of the dictionary. So it's generic again. It accepts a type key and the type value. And it extends the dictionary of the type T key and T value. Okay? Now, here we want another thing, and that's an interface from Unity Serialization callback receiver inside Unity Engine. It implements two methods, on before serializer and on after deserialize. So here we want to serialize, come on, fields. One serialized field is a list of T key, we call it keys, and instantiate it immediately. And another one is a serialized field of a list of T value, we call it values, equals to new list of T values. Okay, now on before serialized, here we want to clear the keys and the values. Okay, after that we loop through each key pair value of T key, T value, we call it pair, in come on, we call, where am I? Okay, we call it, not that, pair, come on, in this. Okay, and where am I missing? What am I missing? Ah, come on, I'm dumb. In this, there we go, a key pair value of T key and T value. Now it's working, and we call it pair. There we go. Now we say keys dot add our pair dot key and values dot add our pair dot value, and that's our serializing of our arrays. So before we start serialization, because we marked these two fields as serializable, they will be serialized. But before the serialization, we clear them, and inside this dictionary's inherited class, so we can use in this, and this refers to this dictionary inheritance class, we get the key pair value, and we add the key to the keys and the value to values. Okay, so we populate the list. Now after that, of course, because it was done before serialization and it generates the list, then the serialization happens on the lists. Now when we are deserializing back, we have two lists that are deserialized. Okay, now we want to make our dictionary. Because we are inheriting from dictionary, we have the clear class method. Okay, then we say if keys dot count does not equals to values dot count, then something happened in between, so we want to throw new exception, and the exception is a string that format. We say there, and come on, text, there are the first element of the format, keys, and come on, one, values after deserialization. Make sure both key and value types are serializable. It means that we had problems. Okay, Now for the 0 and 1, we want keys dot count, and for the 1 we want values that count. Okay, and if I type it, it will whatever. So after that, we are sure that these two are equal count, so we can use any one of them. We say for int I is keys dot count, so we are looping through I on the count. We say add, because add is the method of dictionary and we are inheriting from dictionary, we can call it keys of I, the values of I. This will populate our dictionary. So because we are inheriting from dictionary, we already have all the internals of this dictionary. When the deserialization finished, we clear the internal dictionary array, or I should say collection. Then we check the count. If the counts are the same, then we populate our internal collection with the keys and the values from deserialization. So before serialization, we are populating these two lists. We then serialize them. After deserialization, we just clear our internal collection, read those keys and values that were deserialized, and we populate our collection from them. So if I come to test, now I can say, no, not here, okay? Now, there is one step remaining that we need to do. This by itself won't work. Unity won't serialize this guy because it's still generic. So we want to actually make our own instances of this generic as classes. So we add another class, we call it dictionaries, okay? And we remove this part. So how we do that? We say serializable. So we are making a public class. We call it, for example, string int dictionary, because I know I will use it. And we inherit from serializable dictionary of type string, int. Now, if I come and sorry, it's a class. Okay, so if I come inside test, mark this class as serializable. Now inside here, I can have string int dictionary. We call it, for example, IDs equals to new string dictionaries, and it will work. Okay, and now this guy will be serialized if either we mark this guy with serialized field, where is it? Serialize field, okay, either that, or we make it a public class, public field. Either one of them will serialize this dictionary of string and integer properly now. Okay, so this is a sub-step that we need to do, don't forget that, for any dictionary type that we want to serialize. Okay, cool. Now I will keep this not the test goes into common, god damn it. Okay, the interface goes into interface. Okay, so in next episode I will add few more things. One of them, actually in few episodes, I will have a class for our reflection utilities. So I will have that, and it will be a static. Then I will have let's see, a conversion utilities. So another utility class, conversion utilities, and it will be static. Then I will have a class. I will call it values. This class will be a serializable class, and this will be responsible for any time that I want any form of value on any class or node. What do I mean? I'm planning on the node editor to have metadata. Now, the metadata can be different type of values. For example, integers, strings. I'm not sure if animation curves would be a good example, but maybe animation curves. Who knows? At the same time, for our node outputs, if you recall, we had an output value, and right now it's a float. I want to be able to assign different type of values to each node output. So this class will be used there at the same time. So I will comment it to be used as metadata and node output values. So a class that will be used in two different places. But we will see how it will work. So we have values to cover, conversion utils, and reflections. Okay? And next episode I will start with reflection. Then I will go back to conversion utils and then the values. Until then, have fun everyone. Bye-bye.